name's Noah. I'm the COO over at Battlesnake, and I'm here with Max and Hannes, the creators of Niedersnake. And we're doing the first interview to talk to them about, how they got started and what's Battlesnake to them. So thanks so much, guys, for joining us today.
I wanted to tell how we got started. So Nicholas and I were doing this AI lab at our university, and which basically started with Battlesnake in I think it was October 2018, and then for a long time we actually did MIT's Battle Code, which is in February 2019, and then afterwards we had maybe 2 weeks before Battlesnake, and somebody at our department institute was already working on a deep Q network, so a deep learning approach for Battlesnake, and he wanted to go to Canada anyways. And they were only 2 people, and they said, yeah, we can send more guys to Canada if you come up with something. So we were like, yeah, we only have 2 weeks, we can't make anything complicated. So we just wanted to make a classic approach using a tree search to compare the deep learning approach to. Yeah, and that's what we implemented in those 2 weeks, and then we traveled to Canada.
Gave it a ridiculous name and competed in the intermediate division.
Yeah, of course, we chose a name that we know nobody would be able to pronounce. That's the only reason we chose that name. But, yeah.
I mean, it works. I mean, everyone recognizes your snake. They can't say it, but they recognize it instantly. Can you say it so we have it recorded so we can, always play it back whenever we need to? Maybe just like as a soundbite.
Niedersächsische Kreuzotter.
There we go. Okay, I'll send it over to Chris,
going to be
and he can practice it over and over and over again. So that's awesome. That's really cool that you're using Battlesnake to learn more about deep learning and building out and experimenting with the tree network. So what, I guess, going into my next question is what has Battlesnake helped you learn specifically? What have you used it to experiment with?
First of all, it taught us a lot about game theory. Of course, you have AI classes or something in the university, but actually implementing it and finding out the kinks of what is working, what is not working, what kind of theoretical value is in solving a game in some way. So we took the research approach, I guess, to the game to first of all do a lot of research in how are you going to, or how is Minimax tree search actually implemented, then implementing it, and the way from research papers towards actually having something that is running was really interesting for me. And basically starting with nothing and getting there through iteration and constant improvement to something that actually plays well and you can always see it improving. That was a lot of fun. So you start with something really easy and you continuously improve it, and you see, oh, we could tweak this, we could tweak this. And then you come up with, hey, I found this paper online. They're doing this, for example. We compared a lot to Tron, for example, which is a classic example in AI agent building, basically. And we read up a lot about the Google Tron challenge in 2010, I think, with what heuristics are they using for research and stuff like that. So basically doing a lot of research and then actually getting to implement it and test it was a lot of fun, and brought me a long way again with reading research papers and implementing it. So that's something, that's fun.
Cool. Did you get to experiment with any new technologies that you hadn't been able to find an excuse to play with before, or did you just use things that you already knew?
Most of the theoretical concept of most of the algorithms were there since we had seminar papers or whatever about them, but actually getting to implement it was something new for me totally. Yeah.
Cool. And how's your approach to Battlesnake evolved? You said for the Victoria tournament, you just did a classic tree search algorithm, and then what are you doing now? How has Niedersnake evolved over the year?
Yes, so we first started out, of course, with min-max and then alpha beta, which is the obvious improvement over min-max search. But then we realized that it's not very good for the early game because you have all these players and alpha beta kind of fails for you. And that's why we searched for ways how we can play out n players or multiplayer games, more than 2-player games. And then we found this quite old algorithm called max n, which is just like a n player variant. You can have any amount of players to simulate the early game with 8 players. But then we realized that 8 players is a bit much and you can't really go in depth with 8 players. So we looked for ways how we can reduce that complexity, and that's when we started like masking out certain players. And that was also the topic of the paper that we published at a German conference about Battlesnake, how we reduce the search complexity by like locally masking out certain players.
So if you basically want to know how Battlesnake or how Niedersnake or the Niedersächsische Kreuzotter worked last year, you can just type in Battlesnake, what is it, adversarial AI or something into Google, and you will find the research paper Max and Niklas published last year.
It's the first result on Google Scholar for Battlesnake, so yeah.
It's basically the first ever research paper about Battlesnake.
Yeah, the rest is
awesome.
biological. So
that explains how we approached, or how we still approaching basically the gameplay with Niedersnake. And we also tried out quite recently, actually. We also tried in the arena for a bit, leading up to the last tournament. We tried MCTS, so the Monte Carlo tree search, which is something that is a different approach. It's also tree search, but in a different way, kinda, where you're trying to play out as many games as possible and try to find a way through that. That is something that AlphaZero and AlphaGo use, the Google Go AI player, which beat all the world champions. They used it in a different capability, and they had $15 million to train it. So we are not there yet. But we got to play around with that and like compared it to our current approach, and our current approach still prevails. So we're going to stick with it, and we're just going to figure out how to improve the current approach. That is based a lot about, at some point you reached, you look far ahead enough, or you look you look to a certain depth in your play, basically. So you look like 5 turns ahead or something. And then the 500 milliseconds time limit kicks in. So we can't look deeper. So at that point, we have to have some kind of heuristic, some kind of metric to figure out how well is this certain state for us, and how bad is it for everybody else, or how good is it for everybody else. And this is some kind of heuristic where we right now look on like some details, which is also published in the paper as well, on what kind of features basically we're looking at. And right now we're trying to figure out how we can employ reinforcement learning to learn those features automatically and the weights for those features automatically, in the hopes of finding a smooth, better heuristic that is able to perform better with the same algorithm, basically. So basically just the value function we're trying to replace.
Cool. Sounds like you're going pretty deep into on this.
That's also something that is really cool about Battlesnake. You get to like look at recent papers and recent algorithms, but also stuff I'm looking at right now to like train the reinforcement learning is like from 20 years ago, but still employed and still used. So it's good to like actually learn that and figure it out, because we never heard about it in university, I think. Yeah. So, yeah.
Cool. It's opening up a lot of avenues for self-learning and self-teaching, right?
Yes.
Cool.
Which is pleasant.
So I guess like that's one of the things that you really like about Battlesnake. Like, what would you say that you enjoyed the most about Battlesnake? Like, what's the part that keeps bringing you back to Battlesnake?
Yeah, well, first of all, I've done like a number of AI competitions now, and regarding like the rules, Battlesnake is the least complex, which in my mind makes it the best, because the rules of Battlesnake are extremely simple. Like, there's no doubt about it, but still, like, you can go so far with them, and I don't think anybody has reached like the full potential of Battlesnake yet, and we can't say there's like a definitive best AI out there yet, and people are still pushing those boundaries, and I think that's really quite amazing, like how complex such a simple game really is. And also, of course, the fact that as a human, I mean, you've played against it, you said, at AWS, and we've also played against it here on our keyboard. And when you're watching these snakes, you're sometimes wondering what are they doing? And then you're playing against them yourself, and you're starting to realize how good they really are. Because when we've played against our agent, even with it like limited to like 1 or 2 depth, not 500 milliseconds, and you realize that you don't stand a chance against it, and that's also quite nice.
Yeah, and I really like about it as well. It's an easy game. Everybody understands it. Everybody's hooked by it. So we showed it to a few friends, like just like the final game of last week or something.
Yes.
And they're all like, "Oh, this is so cool! How do you do this?" And like, how could I get started with it? So there's a lot of even like people who don't really study computer science or anything, who never really programmed. You have to like break it down to the basics to explain it to them, and they're hooked by it because it's cute, it's fun, it's fast, it looks. Sometimes it looks smart, sometimes the snakes look extremely stupid, which is also fun. So there's a lot of like variation in what appeals to people, and that is a lot of fun to like be part of that and say that that's something I made.
Yeah, I mean, it was like 3 a.m. when we watched the Winter Classic. It was like 3 a.m. and we still had people over here who don't study computer science or anything at all. And they were like, I can't imagine I'm doing this right now. It's Saturday, 3 a.m. and I'm sitting here watching Battlesnake. But I'm actually amazed by it, and it's so exciting. So yeah, people really get hooked.
That's awesome. That's super cool to hear. And like, that's one of the reasons we love Battlesnake too, is like anyone can watch it and be like, oh, I instantly understand what's going on here. And it's really exciting to see.
Yeah.
Cool. So I guess like, what do you tell those newcomers about Battlesnake and like to get them started? Like you've got some of these friends who are like, how do I do this? What's your advice to them? Like, how do you get started? What do you send them? What do you tell them to do?
So the beauty about Snake is it's easy. Everybody played it before, so everybody has an intuition. What are good moves? What are bad moves? And the difficulty is trying to express that in code, right? First of all, you can point them at all the starter snakes that are out there. There's an abundance in every language, basically. I think C#, Kotlin, whatever, Python, Go, everything you want to do, every language you want to do. There might be C++ soon by us, maybe. So it's like everybody in their favorite language can get started. If they don't program, maybe start in Python. I think it's the easiest language. And it's like easy to get. And then the trouble is, well, start with something simple. You have an intuition how it works. You don't want to get trapped in a corner. You want to like move away from everybody, basically. If you're the shortest snake, you want to try to get as much food as possible. Just something like aggressive, greedy eater, something like that, which is something we did in the lab in the university as well. So we had like a reduced version of Battlesnake just in a local Python environment. And everybody basically did like a, hey, I'm going to like simulate one move into the future and see what happens, and trying to find the best move just locally with seeing what can my opponent do, what can I do. And that is something that already gets you probably quite far in the beginner stage. And even maybe in the intermediate stage, I don't know. It depends on basically who's competing and how your luck is, but just something really simple can get you far already. So it's the challenge of maybe learning how to program, which is kind of big, but the starter snakes help a bit. And then trying to figure out how can I express my typical intuition in code and rules, basically, for my snake. Mm-hmm. And trying to do this abstraction is something a computer scientist or a developer does all the time. So it's a great place to start. And yeah, come to us if you have questions. That's what we tell them, I guess.
I mean, that's a good place to start. Cool. Yeah, I mean, I don't have that's all the questions I have. Thanks so much for sort of joining us today. I'm sure it's a little bit later over in Germany. What time is it over there right now?
7 now. It's like 7 p.m. So it's not too bad.
No, it's
not too bad. Yeah, just after dinner time. Perfect. Okay, well, yeah, thanks again, Max, Hannes, for joining us. And we look forward to seeing Niedersnake perform for the rest of the Winter Classic. And we'll see you in Victoria.
We're excited. Yes. Thank you for organizing this awesome event. It's really fun. It's really fun to be with, to be at, and it's organized really well, I think, as well.
Yes, certainly.
Cool. Well, great.
Yeah.
Well, that's what we like to hear. We're always trying to iterate on that stuff. Okay. Thanks so much, guys. And we'll see you on Saturday at the second day of the Winter Classic. And we'll see you in Victoria in March.
Yeah.
See ya.
Auf Wiedersehen.
Auf Wiedersehen.